Hello students, welcome to IMS GATE Academy. But in the foundation course, I started the electronic devices and circuits. But so far I completed the topics of insulator, conductor and semiconductor. In the semiconductors I have done intrinsic, and also in the last class I did on extrinsic semiconductor also, N-type and P-type I completed. But in today's session, I would like to explain what is drift current density and diffusion current density, and also how to form the PN junction diode. One by one we can discuss, understand now. Now initially I wish to start with the definition of the diffusion at first. Without knowing the diffusion, we can't do anything. Diffusion is more important. Yes, I would like to start the diffusion at first. Diffusion and drift both are very, very important. Based upon this mechanism only, the work of PN junction diode is possible. Yes, Pragya Tripathi. Yes, good evening, sir. Yes, diffusion. How to define diffusion? Suppose I selected a type of semiconductor. This is the semiconductor. But this semiconductor does not contain uniform concentration of electrons or holes. No uniform no uniform concentration. One side concentration of electrons or holes are higher. On the other side, I don't find the water concentration more. In that case, the mechanism of diffusion is going to initiate in the semiconductor. Catch my point, what I said. If in a semiconductor, the concentration gradient is existing, then we can find the mechanism of diffusion, I said. How we can define the diffusion? The movement of charge carriers from higher concentration to lower concentration is called diffusion only now. How this mechanism is done? Because of the temperature only now. When there is no temperature, we cannot find the diffusion mechanism in the material, I can say. So I say one side I got concentration of holes more. Holes are electrons, no problem. This side we got the higher concentration. Other side I got the lower concentration here now, whether it may be electrons or hole. Then what is going to happen? The movement of charge carriers are possible from higher concentration to lower concentration. This mechanism we can call diffusion. But how long the process of or the mechanism of diffusion is going to take place in this material? Here, until the concentration on both sides are equal only now. Up to that extent, it is going to take place in this semiconducting material. Understand my point now? So how we can define this diffusion? The moment of charge carriers from higher concentration to lower concentration. Higher concentration to lower concentration. Higher concentration to lower concentration is called diffusion, I can say. Like that we can define the diffusion. I think students followed the definition of the diffusion here now. But here it is required one more point. How we can determine the current density in diffusion? Diffusion may be possible by using the electrons, otherwise by using the holes also possible now. But I would like to give here now, just I want to give one form, condition, one formula is more important now. Without knowing this formula, we got to diffusion current. How we can get now? Yes, I will give now. diffusion current density we can know. Current density due to, suppose it comes necessity to use current density due to electrons I want to take now. Due to electrons. Current density means what current density? Diffusion current density. That is very important. Diffusion current density due to electrons. Due to electrons means we can put J suffix n. J suffix n is nothing but due to the diffusion only. This is going to take place. This diffusion current density is due to electrons. Is possible now. That can be calculated by Q into d suffix n into dn by dx. dn by dx. This formula is applicable to find out the current density due to electrons in diffusion is calculated by this formula. The Q is the charge, d suffix n is said to be diffusion coefficient, dn by dx is nothing but the slope. The slope of the what now? The change of what the concentration gradient only, that is exactly we can say. The concentration gradient we can call dn by dx only now. But in case you want to find diffusion current density due to holes, suppose. Due to holes means we can use the formula J suffix P diffusion. That is very important. J suffix P diffusion. That can be calculated by minus Q into dP into dP by dx they will apply. With minus, it is very important. This is possible. Sir, here we are getting the Jp is nothing but with minus, there you are getting the plus R. Exactly in the current density of the holes with minus, for electrons means the charge of electron is nothing but the minus of 1.6 into 10 power minus 19. Then minus into minus becomes a plus only. That is why we got Jn is nothing but a plus sign. This is with minus sign only. Anyhow, by using these formulas, you can find the what now? Diffusion current density only now. The next one here required is drift. What is that? Drift is very important now. Next one's drift. DRSRE. When drift is possible? Drift current we are going to use in the PN junction diode generally. When drift current is possible? When drift current is possible means whenever electric field intensity is existing in any material. Otherwise, the potential difference is existing in between the what now any 2 points. Then only we can find drift mechanism only now. Without the existence of the electric field intensity and potential between the any 2 points, at the time we cannot find the drift current only now. So we can define only one point only now. If current flows due to due to application of electric field or due to potential difference we can write it now. Due to potential difference. difference. Due to potential difference also possible. Due to potential difference, then it is known as, the current it is passing due to the electric field or the what not, due to presence of the potential difference to think it. So we can call it as a drift current only. Drift mechanism is occurring due to the electric field and potential difference only now. But due to this some current is passing due to this drift, it is known as a drift current also we can call. This is called as a drift current only now. That is very important. So where that drift mechanism is possible? Is it possible to find the drift mechanism in conductors or in semiconductors? Anybody can give answer for this? The mechanism of the drift is possible in the semiconductors. The mechanism of the drift is possible in conductors. Conductors are semiconductors. Anybody has got idea? In both materials only now. The mechanism of the drift is possible in metals and also semiconductors also. That point is very, very important. We can write now. The drift mechanism is possible. Drift mechanism is possible. Mechanism is possible. Is possible in where? Metals and semiconductors. In both materials we can find the mechanism of the drift. Semiconductors also, that is very important. Semiconductors also possible here now. But how the current density due to drift is calculated? That formula also very important. I would like to give that formula also. The current density due to drift is directly proportional to electric field intensity. When there is no electric field intensity, we cannot find what? Current only now. Current density equal to current by area. Current, if you want to means multiply right hand side value with area only. Directly we are going to get the current also here now. Instead, anyhow, current density due to drift is nothing but the E. Then how you can determine the current density? Current density due to drift is equal to, that proportionality constant is taken as a sigma. That is the conductivity, everybody knows. This is the symbol we are going to use for the conductivity only now. Conductivity into electric field intensity is nothing but the current density due to drift, I can say now. But here the current density, current density due to the drift is possible by using the electrons and also by the holes also possible now. If you are calculating current density due to electrons in the drift mechanism, you think it's so. In that case, how we can take the formula? We know very well current density equal to what not, the sigma equal to, we know very well, charge density into mobility. Charge density into mobility is nothing but the conductivity. So that into electric field intensity only now. Charge density is nothing but the concentration of electrons into charge. That is taken now. That is the charge density. N into Q is nothing but the charge density into mobility. Mobility of what? Electrons into electric field intensity. By using this formula, you can determine current density due to drift mechanism, we can say that now. But if you want to find current density due to holes in drift mechanism, there the formula will be taken in the place of N, it comes P only now here now. I can write current density due to holes due to the mechanism of the drift. We can get from concept, but the conductivity into electric field intensity is same formula. But in the conductivity, charge density of holes very important here now. Because charge density due to holes only here required now. In the place of N into Q, I can write P into Q. That is to be multiplied by mu P into electric field intensity E. Yes, this formula is applicable to find out the current density only now. So these are all very important. So I explained what is diffusion, what is the drift. These points are very important. Now by using this information, how we can do the function of the working principle of the PN junction diode, we can see now. Next ones, PN junction diode, I will enter now. PN junction. PN junction. PN junction means PN junction diode only, exactly. PN junction diode we can write. This is very important, and certain number of formulas will come here now. By using those formulas, I will do certain number of the problems also. What those formulae related to the PN junction diode, I will give clearly now. But everybody know very well, the PN junction diode application, it can act as a rectifier, it can act as a clipping circuits, it can act as a clamping circuits in applications. But here our work is how the PN junction diode internal phenomenon is taken place. That is more important. But initially, just for your understanding purpose, I am giving what is the diode symbol. This is the symbol of the diode. Next, I will draw the what now? Internal configuration clearly now. And also we can draw the what now? The energy band diagram of the PN junction diode also. One by one I will explain. When it is a forward bias, how it can act. When it is a reverse bias, how it is going to act. And different parameters of the PN junction diode also I will explain one by one. Understand now. This is the symbol of the diode. This is the symbol of PN junction diode. This diode can also be called as a crystal diode also. This can also be called as a crystal diode only now. This crystal diode is used in the place of what? Vacuum diode. Initially it is so used vacuum diodes. In the vacuum diodes you got the 2 electrodes within the what now? Vacuum tube only now. And functioning is done. The size of that is a very large, and also it is going to consume the power of the more only now. But when the at the time of by the arrival of the what now this crystal diode, the size of the diode became very small, concise size only possible now. And also what happened now? It is what now? As compared to that, power consumption also very less only possible here now. Understand? As compared to the what now vacuum diodes, the power consumption made by these semiconducting diodes will be very less only possible. Anyhow, this is the symbol. This side we can call it as a anode A. This side we can call it as a cathode only now. We are putting here now what in the symbol we are using one arrow direction. This is arrow. I have taken arrow. Symbol I have taken. And also one line segment I have taken. One bar or line segment. Bar or line segment I have taken. Line segment or bar. We can put one more. Why that? What it indicates? Arrow indicates what? The direction of flow of current. The direction of flow of current means it is a one direction only possible, unidirectional device only now. It will allow the current in one direction. To specify that arrow is given, though it goes current in this particular direction only now. In the reverse direction, we cannot find any current. That means the line segment indicates it can oppose the what now? Current through the what now? Other side only now. Other side current will be stopped. That is just symbol only we can say. But how that PN junction diode will be forming, I will explain now clearly you watch. How that will be means, the structure of the PN junction diode will be drawn in this way. This is the structure of the PN junction diode. This is P-type material. This is N-type material. In the P-type material, you can find the majority carriers of holes. Along with the holes, whenever you are having the holes like this, you think it's so. There you can find the ions also to neutralize. Hole is existing means, positive means here the negative is possible. Negative ions are possible. Hole is existing means negative ions are possible. Hole existing means negative ions. Ions also possible to neutralize this. And here also what happened now? So many negative ions are possible. Along with the negative ions, we can find the what now? Holes also here now. Number of the holes. So what are the majority carriers are existing in the P-type extrinsic semiconductors means the holes only possible here now. But in n-type extrinsic semiconductor, we can find number of electrons. When the electrons are existing here means ions also going to exist. When an atom is losing, how this electron is what? An electron which is going to remain as an excess. It is an excess electron when you are adding the what? Pentavalent atom only now. When an atom is losing one electron means it becomes a what? Ion. When it is losing one electron means it becomes a one positive ion. That is why when an atom becomes one positive ion due to loss of one electron. This electron here also one hole here you got means one negative ion is going to form in the what now atom only we can say. When an atom is losing one electron means again one positive ion is possible. Like that number of positive ions and number of electrons also existing in this material. Like that it is going to exist only we can say. So in the n-type extrinsic semiconductor we got only electrons only now. But the students can have one misunderstanding part, misunderstanding will have. What is that means? Whenever the PN junction diode, how it is forming means many students will say one p-type material you take it, one n-type material you take it, you combine both, then immediately PN junction diode is formed. No, 100% impossible to form PN junction diode such a way. Nobody will combine p-type and n-type directly only now. If you form such a way means you cannot find any conduction of the current only now. But why it is not going to form, sir? Why it is not going to flow the current in the what now? P-type and n-type if it is combined, sir. At the time when P and N are combined, you think it's so. At the time, the barrier which is formed in between the p-type and n-type will be a very big only now. The high resistive barrier will be forming only now. When high resistive barrier, whenever it is forming, it doesn't allow any current to flow through the what now, that PN junction diode only now. Because practically nobody is going to allow the p-type and n-type to combine together to form the what now, PN junction diode. But how they can form then, sir? They will select the what now? One intrinsic semiconductor, semiconducting material. They will take one side like that. Semiconducting material is taken. And they will allow the what now in the same material. This is a pure type of semiconductor initially. It is an intrinsic semiconductor. Then what they will do, by using the mechanism of the diffusion, they will try to allow the what now number of the holes to develop in the material. By using the mechanism of the diffusion only now they will allow inside. By using the mechanism of the what now same diffusion, they are going to allow the electrons also inside of the same material only now. Then it is going to form the PN junction diode now. Sir, how the diffusion mechanisms are? It is very simple. You take the what now intrinsic semiconductor, what they will do? The p-type semiconducting material, p-type extrinsic semiconductor material just dropped on the surface. P-type material is dropped on the what now intrinsic semiconductor. Then the mechanism is applied. What now? To flow the what now number of the what now holes to move. P-type material will allow the what now number of holes to develop only now. So number of the what now holes are going to produce and passes through the what now this intrinsic semiconductor. The other side, a small portion of the n-type material is allowed only now. N-type material is drop is made. Then what is going to happen? Because the drop of the n-type extrinsic the pentavalent atom, sorry, a pentavalent atom is placed on the surface of this intrinsic semiconductor. At the time, it will allow the what number of electrons to diffuse inside of the material only now. Then after they will try to remove this portion only now. The top portion they will remove. The side holes are what now diffused. This side electrons are diffused only now. At the time, what is going to happen now? A junction at which these two will reach. They will come this side electron, this side holes will come. One junction is going to form where they are going to have the contact. In fact, we cannot find any junction. It is not visible to the eyesight also now. We made an assumption there now. A junction means what is the meaning? When the electrons comes to one side, the holes comes to the other side, they will try to have the what now contact. The point at which they will have the contact is said to be what now? PN junction only we are saying now. They will call it is one of the PN junction only now. Understand my point now. Anyhow, the holes we got it now. Along with the holes, we can find the what now? Ions also inside of this material now. Yes, that same point I explained here now. The p-type contains number of holes. Along with the holes, we can find the what? No, negative ions also. In the n-type extrinsic in the n-type material, we are finding the what? No, majority carriers of electrons. Along with the electrons, we are finding the positive ions also here now. Then how the mechanism is going to take place inside of this PN junction diode. We didn't connect any external supply here now. Without, it is an open circuit only now. This PN junction diode is an open circuit. In this structure, what are the mechanisms are possible? You can understand clearly now. What is going to happen here is, just listen now. You'll get the clarity of the subject. But in this case, what is going to happen here now? Next figure, this is the figure 1 I have taken for example, just understanding purpose I am giving. This is the figure 1. In figure 2, what I did, the same p-type and n-type material I got. This is p-type, this is the n-type. There is a junction, imaginary junction made here now. This side number of the holes you got, this side number of the electrons are there now. Do you have the concentration of the holes on both sides equal? We cannot find. But the n-type means we got the number of electrons. Along with the number of electrons, certain minority carriers also exist practically. They are nothing but the holes also existing inside of the material now, minority carriers. Here the holes are the majority carriers in the p-type extrinsic semiconductor. Along with the holes, it can have the minority carriers of electrons also in the p-type extrinsic semiconductor. But in this material, one side concentration of the holes are higher, other side concentration of the holes are less. This side we are finding concentration of electrons more, other side concentration of the electrons less only now. It is existing. What? Potential gradient is existing. Potential gradient here means what here now? The difference of the concentration of the electrons and holes are existing in the material only now. Whenever there is a what now? Difference of the what now? Potential what difference of the concentration is existing, the mechanism of diffusion is going to take place only now. Now what is going to happen now? Because of the diffusion, number of holes are going to move from what now p-type to the what now n-type only now. In the same way, number of electrons will be diffused from n-type to the what now p-type only now. At the time, how that the diagram will be drawn means, please watch it. Here we got the number of holes like this. Number of holes are existing this side. And here, one small layer is going to form. But certain number of the holes are reaching to this side because of the diffusion. Because of the diffusion, here reached only now. Due to diffusion, certain number of electrons moved from p-type to the n-type. In the same way, sudden this side we got n-type material, we got number of electrons. Majority carriers are electrons, minority carriers are existing, but they are holes only now. Understand now. But due to diffusion, because we didn't connect any supply, external supply, it doesn't have any electric field intensity. In that case, what is possible? Diffusion only possible. Due to diffusion, certain number of electrons are going to move from n-type to p-type. Certain number of electrons are moving from n-type to p-type. Here also possible. Like that, mode only now. Catch my point. These are nothing but the positive charges. These are all nothing but the negative charges only. Portion we are calling as a depletion region only now. This portion I can call it as a depletion region. Depletion region. Due to movement of electrons and holes in opposite direction, it can form depletion region. Or we can call one more name, space charge region. We can call one more name, space charge region also we can call. Space charge region we can call. Or one more name also we can call, high resistor region also. High resistance region. High resistance region also we can call now. Any name is allowed, this depletion region. But these are all said to be ions only here now. The depletion region contains electrons are holes. They are nothing but the ions only now. Why it is said to be ion? Initially, this side, in the p-type material, we got the hole, this side. Other side, we got the electron. When the electrons comes from the what now, n-type to the p-type, it is going to recombine with the what now? Hole. When the recombination of the electron and hole is taken place, there ion is going to form. So here, these are all nothing but the ions. These are all nothing but the ions only possible. Understand now? They are not free electrons here now. They are not free holes also. This is a depletion region is forming. Because of the, but how long this diffusion is going to take place in this particular PN junction? How long the process, the mechanism of diffusion is taken place? Because when the diffusion is increasing, diffusion process is increasing more and more, you think it's so. Depletion region also going to increase more and more only now. But after some time, that diffusion mechanism will be stopped. Why it is stopped, sir? When it is stopped, sir, means you can explain clearly now. In this case, when the holes are moved this side, here the positive ions are formed. This side, holes means positive ions are formed. When the electrons are moved and recombined with the hole, you think it's so, negative ions are formed this side. Positive and negative, this is going to form. In between these two, electric field intensity is going to increase only now. From positive to negative, electric field intensity is going to increase. When the mechanism of diffusion is propagating, what is happening? Depletion region is slowly increasing. Then electric field intensity also increasing only, we can say. When electric field is increased, what is going to happen? I said already, when in a semiconductor or metals, electric field intensity is existing, or potential difference is existing, then the mechanism of drift is possible, I said now. Here initially we are finding the diffusion only now. When the electric field intensity is increased, immediately what is going to happen now? That will allow the mechanism of drift inside of the PN junction diode only now. Due to that drift, what is going to happen? This side n-type material contains, catch my point, n-type materials contains, what it contains? Certain number of, what you can say, this side we are going to find what now? Minority carriers of what is possible? Holes are possible this side. This side holes concentration we are finding. Minority carriers of what is possible this side? Minority carriers of the electrons are possible only now. That means because of this, but these minority carriers are immediately try to move from n-type to p and p-type to n to develop the what now? Drift current only now. Whenever the what now, due to diffusion current is going to increase. Due to the what now? Drift current is going to increase. Both are in opposite direction. Whenever the drift current and diffusion currents are equal, and immediately what is going to happen now? The process of what now? The mechanism of diffusion is stopped directly now. Once the diffusion is stopped, that depletion layer is going to remain as a stagnant manner only now. It doesn't increase any more extent only now. Catch my point. Initially, p-type and n-type material, just we can assume p-type one side, other side you got the n-type. The p-type contains the number of majority carriers of the holes, n-type contains the what now? Majority carriers of electrons only, I said here now. Then what I said in here now, because initially due to diffusion, the holes are going to move from p-type to n-type, and electrons are going to move from the what now? N-type to p-type only now. Due to recombination of the what now? Electrons and holes, a small layer is formed. That is called as a depletion layer region, otherwise high resistance region, otherwise space charge region also we are saying only now. Like that a region is formed. That mostly possible in micrometers only possible. Very small region only possible. Understand my point now. And also what I am not, because the diffusion current also going to develop only now. Once the diffusion is increasing, electric field also it is going to develop in between the what now? In between the 2 points of what now? This particular junction. From here to here I have taken one junction form. From here to here one junction form I have taken here now. There we can find electric field intensity. Due to electric field intensity, what is possible? Drift mechanism also possible. Because the drift what now? What is possible? Drift current. Because the drift current is possible, that current is always opposite to the diffusion only possible. When those two currents are equal, immediately what is going to happen now? Further diffusion is stopped only, we can say. Then this is going to remain stagnant condition. What is stagnant here now? This depletion layer is stagnant only, you can say. The width of the, catch my point, the width of the depletion layer is a higher or lower depends upon what? Concentration. The concentration which we are having in the, what now? In this material only now. Whenever the p-type and n-type are less doped, you think it's so. P-type and P and N are less doped, you think it's so. Depletion layer width will be very small possible here now. Depletion layer is possible, less only now. But in case you are using the what now? But this the concentration in the what now p-type, but a p-type and n-type is a what now more you have taken now. More doping, what now more, what now? More doping, moderate doping is made, for example. Moderate doping, whenever you made, moderate what now? Depletion layer only possible now. If the high concentration of the p-type and high concentration of the n-type, whenever you had in the PN junction diode, you think it so, then we can find the depletion region width is very large only possible. It's based upon the impurity concentration only, the change is possible. We can say that now, understand now. But because as here the depletion layer is formed in between these 2 points, it is going to develop built-in potential also. Voltage also, because of the increase of the electric field intensity, voltage also developing in between these 2 points. That voltage we are going to call it as a what? Built-in potential we can call. Built-in potential is possible in between these 2 points right now. The every formula I will give. The electric field intensity, what is so developed in between these 2 points will be calculated by what formula? But the built-in potential between the what now these 2 points will be what? How to find? And also total width is nothing but the W here now. The width of the what now this depletion layer is calculated by what formula? They are all very important. Based upon those formula only now, every problem can be done only now. I will give now one by one. Yes, initially I want to take the what now built-in potential. Suppose you want to find the built-in potential, you think it's a built-in potential. Built-in potential, or we can call one more name, contact potential also we can call. Contact potential also we can call that. Potential. Contact potential also we can say. Built-in potential or contact potential or equilibrium potential also we can call. Equilibrium potential. Any name is acceptable. Potential. That means the potential which is forming where in the depletion layer is said to be what? Built-in potential only now. That is denoted by symbol V0. V0 is allowed. In certain textbooks they will write VBI also, they will write VBI or V0. How we can calculate? That is calculated by KT into ln of natural log of NA into ND, NA into ND by NI square. This formula generally they will apply to determine the built-in potential. By using this formula, mostly asking questions in the GATE or any competitive exams. So, you know, here. What I gave it now, this built-in potential equal to KT. KT value is a fixed value only now. But in the problems, he will give sometimes, he will not give also sometimes. The KT value is taken as a what? 26 millivolts at room temperature. At room temperature, you can find. Understand now? At room temperature. KT can also be called as a VT, thermal equivalent of voltage. VT equal to KT also they will write. Thermal equivalent of the voltage equal to KT. 26 millivolts at room temperature. At room temperature, it is a fixed value only. We can say only now. Understand now, KT. But NA means acceptors concentration. Because the P-type and N-type can have the what now? Acceptors and donors concentration only we are having. Na equal to acceptors concentration. Acceptor concentration I can write. ND can be taken as a what? Donor concentration. Donor concentration we can put here now. Ni equal to intrinsic concentration. N suffix I equal to intrinsic concentration. Intrinsic concentration. From this formula, one point you have to know very well. The built-in potential depends upon what are the factors here? Concentration of electrons and holes. Na and Nd. These are nothing but the concentrations only now. When the doping concentrations, these are all. Na acceptors concentration, Nd will be possible because of the doping only now. Without doping, we can't get it now. That's why the first initially V0 depends upon the what now? Concentration. The second one, it depends upon the temperature also. When the change of the temperature is taken place, what is going to happen? When the change of temperature is taken place, Ni value changes only. Intrinsic concentration depends upon the two factors. One is nothing but the type of the material. Germanium can have one value of Ni. Silicon can have the what now? One more value. There's a type of the material is changing means Ni value also changing. When the Ni value changes means what is going to happen? The change of V0 also possible only now. There's a, when Ni is increasing more and more, you think it's so. V0 will be decreasing only now. When Ni is decreasing, V0 will be increasing only now. That's why we can write now. The temperature is one factor, and also what is the type of material also one more factor. And third one, what I said now, the concentration doped in the material also one more factor. To allow the what now? This built-in potential, more or less only we can say only now. Understand? Anyhow, this is the built-in potential formula only now. Next formula. The next formula here required is a width of the depletion layer. How to calculate? Width of depletion layer or depletion region. Depletion region or depletion layer. Width of the depletion layer means this I said now. This is the P-type and N-type material we are having this side. This is P-type, it is a N-type. But there is one junction and depletion region is possible here only. This I can take it as a W. W is the total width we can write now. The total width is a W now. Here clearly one more point also I can write now. Suppose these are the dots I have taken. These dots only I have taken. This I selected as a what now? Junction. Again, this is nothing but the P-type material. It is a N-type. This end point we can take this end point. I can say this end point I can take it as a W suffix N. The N-type material we got. This point I have taken as a origin value. 0. Junction is going to stand as a origin only now. The omega n is a what? Wn is a positive value. This side negative. P-type material can have the minus Wp. I can write now. Wp is possible. Negative they will put now. This total width is a W. So W equal to what plus what? Difference of this Wn minus of minus plus Wp also we can write now. Understand now. So we can write this way also. The W can be calculated by width of the depletion layer or depletion region can be calculated by Wp plus Wn is acceptable. This formula is also acceptable to find out the width of the depletion region only now. So, and also what not direct, but what is the Wn star? How we can determine Wn star? Wn can be calculated by total, but I will give. Suppose you are given in the problem, W is given, Wp is required, Wn is required. When this W, whenever it is given, this by W by, we can take 1 plus Nd by ND by NA we can write. ND by NA. Donor concentration by acceptors concentration is allowed. By using this formula also we can find WN. Sir, if I want to find out the WP, what formula I can use? So you must use to find out the WP, W by 1 plus reverse, NA by ND they will put. NA by ND can be taken here now. By using this formula, you can find the WP. When you can apply these formulas, if you are given the what not total depletion layer only now, the depletion layer width is given, you think it's so, then WN, WP you can find. In case WN is not given, WP is not given, and is asking to find the W without giving the what no, but some data, but directly you want to calculate W value, for example. Suppose you want to find out the W value directly, sir, without using the WP and WN. Yes, we can use one more formula. We can use one more formula. That formula is, I will give just watch. The W can be calculated by width of the depletion layer is calculated by under root of. These are all very, very important formulas in any competitive exams, even in the PSUs or even in the GATE exam, even in the engineering service. Generally, we are going to use these formulas. 2 epsilon, epsilon equal to what? Epsilon naught, epsilon r divided by Q into 1 by N by A plus 1 by N, 1 by ND they will use. By using this formula, the calculation of W will be done. By using this formula only, the width of the depletion layer is calculated by this formula only now. Width of the depletion layer, if you want to calculate this formula, you can use only now. And what about the electric field intensities are? But I said already here now, whenever the diffusion is going to take place, number of electrons will move from the N type to P type, and holes will move from the what now, P type to N type, then forming the what now, depletion layer. In that depletion layer, it is going to increase electric field intensity to cause the what? Drift also, I said no. That is why how to find out the maximum electric field intensity in a depletion layer only now. So maximum electric field can be calculated by this formula. Maximum electric field intensity. But in the problems, it comes to necessity to find out the maximum electric field intensity. That is calculated by this formula, electric field intensity. How we can calculate that? It is denoted by symbol E max. Otherwise, they will put E naught also, they will write like this. E naught or E max. When PN junction diode is an open circuit, we are finding E naught and E maximum. Both are same now. How that is calculated? E max or E naught. I am putting E naught for example. E naught equal to what? Different formulas are there. Minus Q by epsilon. Epsilon equal to everybody knows. Epsilon naught, epsilon r. Epsilon naught value everybody knows. The fixed value 8.85 into 10 power minus 12 farads per meter only possible mostly. Epsilon r relative permittivity. Relative permittivity changes with the change of the materials we know. Mostly in the problems you will give epsilon r. Epsilon naught will not be given. In the problems I will give what is epsilon naught and everything now. Q by epsilon, epsilon equal to that value into WP into NA is acceptable. Acceptors concentration allowed. Minus Q by epsilon W suffix P into NA is acceptable. Otherwise, you can use one more formula also. What is that formula? Minus Q by E epsilon, sorry, minus Q by epsilon WN into ND also they will apply. Even you applied this formula, it is acceptable only now. Otherwise, in this case, WP, WN must be given, sorry. But in the last case, what happened now? If the W is given, WP, WN, you calculate it in the last case. Here, WP, WN is given means how to find out the intensity also we are giving now, understand now. But total width you can find by using this, and also electric field intensity also you can find. And also you can find maximum electric field minus 2V naught by minus 2 V naught by W also allows. 2 V naught by W. By using any one of these formula, you will get the what now? Maximum electric field intensity in the depletion region only possible here now. Now, I would like to do certain number of the problems based upon this. These are all the formulas are possible when PN junction diode is open circuited. That is very important. Now, I wish to do certain number of the problem. You will understand how to. Yes, first problem. I'm giving the problem here. Question. Calculate. Is asking to calculate the value of built-in potential, the value of built-in potential, built-in potential built-in potential, but I want built-in potential, built-in potential. If n suffix a acceptance concentration is given, that is 10 power 18 per cm cube is given, and Nd is given here, donor concentration is given. Nd equal to 10 power 15 per cm cube it is given, per cm cube, 10 power 15, but no, Nd equal to 10 power 15 per cm cube, and also given intrinsic concentration Ni. Ni is given 1.5 into 10 power 10 per cm cube is given. Now, hereafter it is very simple to do any problem. Once you know the formula belongs to the what now? Open circuited PN junction diode, you can do any type of problem. Very simple way. But what is given and what is asking, you see the now. What is so asked in the problem you ask. Calculate the value of built-in potential. Built-in potential means what? Barrier potential. Barrier potential means what? V naught or VBI, we can say. How we can find this VBI? We can write V naught or VBI is the built-in potential. I gave already formula Kt into ln of natural log of Na into Nd by Ni square. Ni square. What is difficulty in the PN junction diode means to remember the formula only. If any student has not done the problem means he didn't muck up the formula only. He has to muck up every one of the formula only now. Then it becomes very simple to do any question. Understand my point now. But how we can find these V naughts? Kt value I said already. It is not specified temperature. We need to think it is a room temperature only. At room temperature, Kt equal to what I gave it, 26 millivolts. It is a 26 millivolts. Kt value. Kt value 26 into what now 0.026 most people. There is anyhow 26 milli. Ln of Na is given in the problem. Na equal to 10 power 18. 10 power 18. What about Nd? Nd is nothing but the 10 power 15. 10 power 15 divide by Ni square. Ni equal to 1.5 into 10 power 10 whole square. 1.5 square means what is possible? What is possible here now? 2.25 is possible. I'm squaring this 1.5 square is nothing but 2.25. 10 power 10 whole square, 10 power 20 is possible here now. I'll get 10 power 21. If you are using the calculator, its value will be 0.75 volts. 0.75 volts mostly possible. That much value is possible. I said already what now, that built-in potential is in micrometers only possible, I said now. The width of the what now, that built-in potential, the width of the deposition layer is in micrometers only possible here now. But built-in potential is possible. What value is possible? Based upon the type of the material. If it is a germanium, you think it's so. If it is a germanium, the built-in potential ranges from 0.2 to 0.4. 0.2 to 0.4 volts possible here now. I say V0 value, practically what they will do, V0 is maintained 0.2 volts to 0.4 volts for germanium. For germanium, that is maintained practically. What about for silicon SAR? If the material is a silicon, you think it's so now. It is a silicon, you think it's so. Here what it is, anyhow, it is a germanium. If it is a silicon material is given, V0 is taken as a what? 0.6 volts to 0.8 volts. Not writing, just wait. I'm writing clearly here now. The V0 value will be 0.6 volts to 0.8 volts. Sorry, 0.8 volts. Oh my God. Just wait 1 minute, 1 minute. We can take back best. I'm writing clearly. Yes, V0 equal to 0.2 volts to 0.4 volts, I said. For what I said? For germanium, no doubt. If it is silicon means I can start from here best. V0 equal to I can get 0.6 volts to 0.8 volts possible for silicon. For silicon only now. Practically, they will maintain such a way only now. We are getting V0 equal to what? 0.75. 0.75 is lying in between these two. So it may be silicon only possible here. Understand? It is a silicon material only possible. Otherwise, we cannot get that much value only now. And I wish to give one more question in your hand now. You please try this one out. The next question I will give. I want to give one more question. For problem is given right now. For an abrupt ABRUFT, abrupt PN junction. This is in the PN junction only. PN junction. PN junction. Doping on P side. Doping on P side. Doping on P side. Doping on P side and N side are N side P side and N side are given here now. What doping is made? That is Na equal to acceptance concentration is given. There's a 9 into 10 power 16 per cm cube is given. Per cm cube is given. And also in the problem, Nd is given. Donor concentration also given here now. Donor concentration is given. Nd equal to 1 into 10 power 16. 1 into 10 power 16 per cm cube it is given. Per cm cube. 1 into 10 power 16 is given here now. And also in the problem, what is asking here now? The total width is given. If total width is 3 micrometers, small width Micro only possible, 3 micrometers. What is the depletion layer width? What is the depletion? What is the depletion? What is the depletion? Depletion width on P side. Width on P side is asking. That is a given problem. How we can do this question? You check what data is given and apply the formula. That formula application only, nothing more. It's a very simple question. The PN junction diode. Understand here now. And in a problem, when for a PN junction diode, it is given P side and N side, or then NA acceptance concentration is given, donor concentration is given, and W is given. Is asking to find the depletion width on P side. Is asking to find WP equal to how much is asking. The width on the P region is asking to find only now. WP equal to how much is asking. When W is given in the problem, you think it's so. W is given in the problem. What is given? 3 micrometers. By using the W, I gave you formula. What is given? WP equal to, I gave already formula, W by 1 plus NA by ND, I gave already. NA by ND is given already. That formula is given. That directly you can substitute the values only now. W equal to how much it is given here now? 9 into what it is given? 3 micrometers. 3 micro. Okay, 3 directly. 3 micro means 3 into 10 power minus 6 I can put now. In meters, micrometers only I have taken now. 3 micrometers I have taken now. 3 micrometers. Divide, no need to convert into the centimeter now, because NA is in per cm cube, ND is per cm cube, cancelling only now. Totally this becomes a constant value. Finally in micrometers you will get answer only now. 1 plus NA by ND. NA is nothing but 9 into 10 power 16. 9 into 10 power 16 by NA value. 9 into 10 power 16 by 1 into 10 power 1 into 10 power 16. 1 into 10 power 16 is possible. And finally, this WP you will get as what a 0.3 micrometers possible. Because you know 10 power minus 6, 10 power 16, 16 here cancel now. Finally, what is still left? 3 into 10 power minus 6 by what is possible here? 1 plus 9, 10 is possible. Finally, 0.3 micrometers is possible. Yes. That is answer. Such a way we can find out the what now? Width in the P region only now. In the next class, we can do the what now? Few more number of the problems, and also how the biasing will be made, and also we can find the what now? Different parameters also. I will explain in the next class now. So next session I will explain now. Thank you.